All good? Hey everyone, it's great to be here. Yeah, I'm going to be talking about Mario Kart, making a CSS game that is Mario Kart 100% CSS. It is not a single line of JavaScript, not a single image. It has 5 lines of HTML, but kind of off in one hand, so it doesn't count. The rest of it is all CSS. If you're worried about the quality of my photoshopping skills here, don't tell that to me, because I worked really hard on this. So, that is not... Yeah, I'm Stephen Cook. You can find me on Twitter at StephenCookDev. I'm going to link right after this talk just to this slide deck, and also just like a slightly more fully fledged version of the game. So you can just check out there if you want to get even stupider than what this talk is going to be going through. I work for a company called Thread. Thread sell clothes online. We have in-house stylists and data scientists who basically work together to give you outfit recommendations. So working for a fashion company, naturally I decided to do a talk on Mario Kart. So, what is CSS? I'm guessing that most everyone here knows what CSS is, but just taking sort of a step back view before we get really stupid with it, let's just sort of summarize its main points. And I think really can be broken down to these 2 things. You can select something in the DOM, so you can say div.foo, and that's going to look through the DOM and find any div tag that has the class name foo. The next thing it does is it lets you style it. You can say background color red, or text decoration underline, and that's going to style that element that you just found. There are a couple of extra things that CSS has as well, like pseudo selectors, pseudo elements, so like the hover pseudo selector, for example. And you could argue it doesn't quite fit into these 2 main things, but you also could argue it could. And regardless, what a game needs to be able to do is to be able to take arbitrary input from the user, take that arbitrary input then needs to be able to mutate state, again in arbitrary ways, and then use that state to generate screen content that is, again, needs to be dynamic based on that state, completely arbitrary. None of those things is what we just mentioned that CSS can do. So why are we doing this? It's no great reason, but for me, at least, it was basically I wanted to see how far I could push CSS. Yeah, this isn't necessarily stuff that you should be doing in production, but I definitely learned a few things along the way that maybe you should use in production, but I think the things that you should be doing should be fairly obvious. So let's dive right in. Can people at the back see that code okay? Cool. So, box shadows. CSS lets you do box shadows. I'm aware I've just been talking about making a Mario Kart game, and now I'm talking about box shadows, and it sounds like I've gone mad, but this leads somewhere.
Yeah.
I think some people might know the trick. It sounds more insane to others maybe. But yeah, you can specify a box shadow. It's you can specify your offset, which color you want it, and the blur radius. While we're going, we can also just comma separate. We can just keep listing off as many box shadows as we like. We can also just get rid of the blur radius entirely. You can just say blur radius is 0, and then you don't get a blurred box shadow, you just get a square that is the original size of your element. We can line these squares up, and then, while we're lining them up, let's just keep going. If our original element is 1 pixel big, we're encoding an image, right? All an image is just saying which color each pixel should be. An image also has very intelligent encoding. This is not very intelligent encoding, and this is our first don't do this in production. But let's get going with that. What we're going to do here is basically just use that technique. I'm just going to make a Mario sprite. So first of all, just show you, this is the page we're editing. It's going to be very fake live coding. So to start off, we're just going to make a Mario div. And then we are going to, first of all, we want to make him 1 pixel by 1 pixel because we're trying to specify each pixel along the way, so the box shadows need to be based on the original element size, so it needs to be pixel by pixel. And then the next thing I'm doing is going to say box shadow. And I've been given some feedback that apparently typing out all 600 pixels of this image is boring. So instead, what I'm going to do is just specify here it's Mario box shadow, which is a variable, which is in this, if I can type. It's in this folder. This file literally just contains a load of variables, a load of box shadows that we'll be using throughout the talk. So if we go back here and refresh now, you can see we've got a little Mario. And I'll get that a bit bigger so people at the back can see. Oh, got a nice little Mario picture. And what we can do as well, I'm not going to go too much into the code of this, but basically this is just a few other elements. It's using the exact same technique, but we're just going to create an output div. So this is just going to have a nice background and wrap our entire scene. We're going to have Mario, but we're also going to have not 3 Marios because that's mad. Instead, a road, and some trees. So refreshing now. Cool. We've got a nice picture. But it's a picture, right? Like, no one wants to play a picture. So how do we add some more stuff to this? So CSS actually just gives us animation out of the box. We can specify this thing called keyframes, which basically just lets you say what you're trying to animate from and what you want it to go to. So here, for example, we've got an animation to do with opacity. So to say, from opacity 1 to from opacity 0 to opacity 1. We've also said that we want the duration to last for 3 seconds, and we want it to be infinite. So that's why it just keeps looping rather than stopping. You can also specify timing functions. So this is a time function that I think is probably a bit less well known, but it's called the steps function. The way you can think about it is basically as a linear animation just goes across, a steps function moves in jumps. So it follows the linear path, but does it in here for exact steps. So let's try and add a bit of animation for what we just had. So the first thing we're going to do is copy this from here. And yeah, throughout this talk I'm going to be copy pasting because it's the Stack Overflow method of live coding. It is safer, just like it is in production. So we want to use this driver shake animation, which is basically just scaling up from a scale y1 to a scale y0.97. So it's basically, we're going to apply this to our Mario element, and it's going to make Mario shrink a tiny bit and then go back up to the full height. And we want to do this infinitely and in steps too. And we also want it to be 1 second. So this is probably a tiny bit subtle for people at the back, but it basically just, I think it's quite a subtle effect, but it just makes it basically look like, the engine's on. So I think that's a bit. But yeah, as I say, that is a tiny bit subtle for people at the back of the room, so let's do a bit more. So we've also got 2 trees. So we're using a before and after pseudo element for each tree, so we can get 2 individual trees in one tree div. I'm going to add in these keyframes. So we have tree left move and tree right move, which basically just transform up the trees to come in. So it scales them up and also translates them in direction to sort of make it look like it's coming in from the distance. And we've also got a fade. So basically they fade in, so it looks a little less jumpy when they suddenly appear in the distance. So let's get our tree left move, 3 seconds, if I can spell. And tree fade, 3 seconds. So that's going to get the left tree working, and we'll do the exact same thing for the right tree, but with the different movement. Now, you can see we've got trees coming in. So we're getting somewhere, right? But it looks a little weird, right? The trees are coming in, but they're coming in sync with each other. It just feels a bit unnatural. So what we can try and do is just make them come in a little offset, just to make it feel a little more natural. So why don't we add in an animation delay. And so this code will work, it'll make them go offset. But when I refresh, you'll notice that there's a slight issue. You you see the tree on the right, it was there just for that initial second. And now it looks good, like now they're out of sync, which is what we want. But that initial second is a pain. But what we can do instead, say minus a second. And now the animation, that starts in the past. So before the page loads, the animation is already going on for a second, is basically what's happening there. When I tell people about this bit, people always think that that's like one of the hacky parts of the talk. That's not the hacky part of the talk. Like, this is a quote from W3. Negative delay, that is like, that is in spec, that is by design. All browsers have to implement this. And if you think about it, like they justify it a bit here, but yeah, if you think about it, it sort of makes sense that you should be able to specify it in the same way that you can specify animation delay of 0. And it is very useful for making things go out of sync without having to have an initial bit where nothing's happening. So that's a good start. We have some basic animation now, but we eventually want our Mario character to be turning, when he's steering. So here's a nice little steering animation. We can't really do this in CSS, right? Like this isn't this isn't a transform, this isn't a basic rotation. So how do we do this? And if we break it down, first of all, into just looking at, each individual frame of that. And if we put them all on top of each other, you might start getting the idea of how old movies work, which is you take all of the pictures and you run them up through a film and just, shine a light through them, and it, makes the illusion of movement. And this is something we can do in CSS, right? Like this is just moving an element upward, that's a transform. We can do transforms, that's no problem. And if we use that steps function that we were looking at before, suddenly we have something that's looking a lot more like the actual turning animation that we were going for. All we need to do is just work out a way to occlude the rest of the picture. So we have one big picture with all the possible states of Mario in. As long as we're only ever showing one Mario at a time, it looks like he's turning. So if we go back then to our original box shadow code, if instead of having the box shadows in the div, what we can do instead is put them into a pseudo element. So if we create an after pseudo element here, and now our original div, that's the container. So we say that needs to have overload hidden, so it, anything that comes out of it is not visible to the user. But otherwise, that after pseudo element, we can put all of the box shadows in there, and that's going to have everything happening at once. It's worth saying as well, this idea of like a sprite where we're moving something up and down, that's not something that like I just made up for this talk. This is something that like actually happens in games. It used to happen a lot more in the web days as well, like with a way of getting like hover effects, but you see it less nowadays. But yeah, this is an actual effect. Just say games use images, we're using box shadows. So let's give that a go. So the first thing I'm going to do is just replace our Mario code. So at the moment Mario's doing everything, it's got all the box shadow stuff in. Now, so the only thing that's really changed here is the fact we've got width and height set explicitly, we've got overflow hidden. I'm using this variable for the height because we're going to use this eventually for working out how much we need to move the image up to do the movement. So get that. We're also then going to add in this stuff. So this stuff is basically the Mario before. This is adding in the new different box shadow because it's rather than just one Mario, we now want all of the Marios going all the way down. And then we're adding in this new animation. And what this animation does is it just changes the margin top. It's using the percentage syntax of keyframes. So rather than saying from to, you can also say like what percentage of the animation we're trying to describe. So here we're saying at the start of the animation, we're at the top. So there's just margin top 0 is just normal. And then halfway through the animation at 50%, we set the margin top to a negative value, so it's going upwards. And then at 100%, it goes back down to margin top 0. The reason for this is because we're looping this infinitely in steps that are based on how many frames there are. So what it's going to do is it's going to go through each individual frame, and then it's going to go back through each individual frame. So he turns left, and then goes back to neutral. And if we give that a go, didn't work because I forgot to add this. So all this is doing is, because we added in that new pseudo element, to instantiate pseudo element as a block level element, which is what we need for block shadows to work. Just an element that's on the screen. So we need to explicitly set content empty string, width 1 pixel, height 1 pixel, and inline block. So now you see we've got Mario, and he's doing his turn. And he's doing that on loop, which is great, but again, not quite what a game is, right? A game is interactive. You can't just watch someone turning on loop. It's a very boring game. So what we can do instead is look at adding in some basic user input. A common way to do this is to use the WASD characters, or at least when you're like gaming on a laptop or something. So basically the A character lets you turn left, the D character lets you turn right, which is great for us, right? Because that's just character input, and we're on the web. Character input is a thing we have on the web. We have text boxes. So here's just a normal text box. And we have some CSS on the left here, which is basically saying, find an input. If it has value equal A, make the border color red, and if its value equals D, border color green. Eventually, we want this to turn into like, turn left, turn right, but just for the sake of these examples, I'm going to use red and green instead of left and right. But yeah, here, this should match, so when the value changes, it should get border color red. Except it doesn't work. And the reason it doesn't work is because there are actually two different types of value on an input. There is the dynamic value and the attribute value. So here, if we start off some HTML, we say input type text, value equal foo. Right now, the value of the text box is foo, and its attribute value is also foo. But if I were to type in foo bar, the dynamic value of this text box is foo bar, but its attribute value is still foo. So if you were to look in the DOM, like look in the inspector or something, and like click on that text box, you still see in the DOM value equal foo. So what we can do is use some JavaScript to sync these things up. So we can say, whenever the input changes, grab its dynamic value and set the attribute value to be what the dynamic value is. So it's going to keep those two things in sync. But I said at the start of this talk that I wasn't going to use any JavaScript. And I sort of feel this is, I was helping someone move recently, and I picked something up to carry it up to their new place, and they said, oh, that's heavy. And I said, oh, no, it's fine, I'm fine. I said, you sure you don't need a hand? I said, no, I'm fine, honestly. Walked a few more steps and realised, oh no, I'm not fine, I've made a mistake. But at that point, it's too late, you've already said no, and you're sort of stuck with that decision. And yeah, that's how I felt when I realised that value doesn't work, and I didn't want to do any JavaScript. So I sort of just banged my head against the wall for a little while. But I eventually found these two superselectors, which I've never heard of before, called valid and invalid. And true to their name, basically they let you match on an input to say if it is valid or invalid. So a way that an input can be valid or not is if you pass in a pattern to the input. So what this pattern is, it's like a regular expression, but here we're basically just matching against the basic string. But if I start typing here, you can see it's not valid anymore because it doesn't match our pattern. So it gets border color red. And as soon as it's correct, it's valid, gets border color green, which is good, right? That is two states that we have. We can go one further as well. We can get a third state in. If we specify a placeholder and then use another CSS selector called placeholder shown, then we can have our initial state. So this is placeholder shown, that's state 1. Start typing in, we're incorrect, so that's state 2. And then we finish, that's state 3, got border color green. So that's 3 different states. And mapping that back into the original problem that we're trying to do, we're trying to get left and right, and obviously like the state of you're not doing anything yet. So here, I've not told Mario to do anything, so there's no keyword input detected, placeholder shown. I push D, you push D, you're trying to turn right. I push A, you've not pushed D, you're trying to turn left. And this keeps working, so you can just keep detecting which way we want the character to turn. It does have the slight downside that anything is seen as the letter A because it's not the letter D. but we just have to trust our users to only push A and D. I'm sure they'll do all this. So let's give that final bit a go. So Mario's just turning left there by himself. Let's get him to actually do something useful. Oh, the first thing actually I'll do, so I always forget this bit, is just to, we actually need the input. So yeah, we get, you do actually need a placeholder, even like here we don't want the placeholder, but if you don't have it, the placeholder shown doesn't work. And then pattern is anything that ends in the letter D. So we've got our input now, we just need to get Mario to listen to it. So the first thing we're going to do, so we've got this Sprite animate. We've got our Sprite animate function, which is getting Mario to turn left. This is doing the exact same thing, but it's using scale x minus 1, so it's mirroring him. So it basically just lets him turn right as well, because he's a symmetric sprite, which is useful. And then the next thing we're going to do is actually be able to steer. So after having that new animation in, there. So what we're going to do is we're going to say, if you find an input valid, look for the element next to it and find the Mario that's next to that input and make him turn right. If you find something that's invalid, make him use this animation, the left turn. And if the placeholder is shown, so if nothing's happening, don't do any animation. So now, if I say D, so he turns to the right, A, he turns to the left. And we can do one final bit just to make this actually turning, because at the moment we're just turning in place, which is a bit boring. But what this does is it, rather than applying to the before super element, which has all the PopShows stuff in, we're now going to be targeting the actual parent container, and we're just going to literally just apply margin left with a transition on it. So it's doing the exact same thing for matching, but it's getting the margin left to apply either way. So now, if we refresh the page, you see we get them to turn with AOD. And that is a very, very boring, but by some definition of the word, which I am going to choose to use, a game of Mario. And I'll stop there before anyone gets bored of Mario. Yeah, thanks everyone for listening. Again, yeah, I'm going to post a link to all this talk and stuff on Twitter, but yeah, thanks.